The composition of functions, so in each of these examples, A and B, is the final answer. Okay, this is after the composition of functions has been done. What they want you to find is what those original functions were, so that you have f of g of x. Now, unlike the other ones, what we do with composition of functions is we try to see, can we see one function inside of another function? So for example, in part A, can you see an x minus 2 inside of something getting cubed? In B, can you see a 3 plus x inside of a square root? So if we're doing that, what we do is we say our inside function is g of x. I'm going to make g of x equal to x minus 2. And what happens to the x minus 2? It gets cubed. So I'm going to make my outside function cubing. Do a quick check. Is f of g of x equal to x minus 2 all cubed? Well, if you did step by step, f of g of x is the same as f of x minus 2. And whatever we plug into f gets cubed. So sure enough, it is equal to x minus 2 cubed. Part B, looking at our inside function. Can you see that you have a 3 plus x inside of a square root? And so our outside function will just be the square root of x. These ones in particular, I like you to look at it this way. There is a shortcut, and if you want to figure it out, right? You remember in the adding and subtracting and multiplying and dividing? I always made one function. Whatever I picked my first function, I always made it exactly what I had to begin with. So there is a way to do that as well, but I won't tell you. You have to figure that out on your own. So what would, if g of x equaled x minus 2 all cubed, what would f of x have to be to still get x minus 2 all cubed? Okay. Questions for this one are 3, 7, and 9.